Hi, in this video, I will be showing you problem number 32 of chapter 12, section 2. Find the magnitude of the resultant force and the angle that it makes with the positive x-axis. So the picture is given. We are asked to find out the resultant force. If there are a number of forces acting on an object, then the resultant force would be the sum of all the forces. So in this problem, it is better we write these forces. The forces are, I can call it by vector OP, the directed line segment vector OP, and then directed line segment vector OQ. So vector OP and vector OQ are the forces. We are finding the resultant force. So if we write OP, vector OP in the component form, so we are going to write this as component form A1, A2, which can also be written as A1I, A1I plus A2J using the standard basis vectors. So in this case, it looks like vector OP, the magnitude of the vector OP is 20 lb, the force magnitude is 20 lb, and it makes an angle theta which is equal to 45 degrees, and also vector OP lies in quadrant number 1, which is important here, which means that its x coordinate and the y coordinate, the x component and the y component have to be positive. So A1 is the absolute value of the vector times cosine of the angle which will be equal to, in this case, 20, which is the magnitude of the length of the vector OP. Then cosine 45 is root 2 over 2, which is equal to 10 radical 2. So 10 radical 2 is the x component. Same way we can determine the y component, which is absolute OP times sine of 45. So which is absolute OP, which is the length of the vector, which is 20, times same thing, root 2 over 2, which is 10 radical 2. So the y component is also 10 radical 2, which can be written as 10 radical 2i plus 10 radical 2j. That is for the first vector, OP. Then I will find out the vector OQ in a similar way. Let's say we'll assume that B1 and B2 are its components. Then B1I plus B2J written in with the help of standard basis vectors. And then in this case, the important thing is that vector OQ belongs to quadrant number 4, which means that the x component is positive and the y component is negative. This is important here. So if we use the same trick that we used before, then if we take vector OQ, which has components B1, B2, B1 would be equal to length of the vector, which is 16 cosine of 30, which is 16 cosine 30 is root 3 over 2, so 8 square root of 3. So OQ would be equal to 8 square root of 3. Then we have B2, which is the y component, is 16 negative sine of sine 30 measured in the opposite direction. So it is going to be a negative sine of 30, which is going to be negative 16. Sine 30 is 1/2, so which will be just negative 8. So this vector OQ, which lies in quadrant number 4, will have its x-coordinate positive and y-coordinate negative. So it is 8 root 3I minus 8j. So vector OQ is 8 radical 3I minus 8j. So we got that 1, 2. The two vectors are written in IJ form in the vector addition with the help of standard unit basis vectors. Now we have to get the resultant force, which is the sum of these two vectors. So the resultant force so it is vector OP plus vector OQ. So if I add the two, I get 10 radical 2I plus 10 radical 2j plus 8 radical 3I minus 8j. So if I add the I components, it's 10 radical 2 plus 8 radical 3I plus 10 radical 2j minus, we can actually write 1j, which is common. So it is 10 radical 2 minus 8j if you combine the i's and the j's. So this is the resultant force. Now we are asked to also find out what angle it makes with the positive x-axis. So we can write this as tan of theta or theta, which can be written as tan inverse of the y component over the x component. It is just like understanding the basic principle of vector A having components A1 and A2, and if this is the angle theta, then tan theta is given by the y coordinate over the x coordinate. And it will give us tan, theta will be tan inverse of the y component over x component. We may want to refer this. So which will be here, the y component, which is, so we have tan inverse of the numerator is 10 radical 2 minus 8, which is the y component, over the x component, which is 10 radical 2 plus 8 radical 3. So if you use your calculator and make your calculator set to degree mode and find out this value, tan inverse of 10 radical 2 minus 8 over 10 radical 2 plus 8 radical 3, you get 12.37 degrees, or approximated to 1 decimal, it will be 12.37, 12.3 to 12.4. So if you reduce it to 1 decimal, 10th place, it is 12.4. That is 12.4 degrees. So you may have to use your calculator for this part of the problem, which is tan inverse of y component over x component reduces to 12.4 degrees. Make sure your calculator is set to the degree mode when you do the calculated part. Hope this video helps.